And now let me introduce the idea of a root diagram. So can I take about 10 more minutes?
Yeah, I'm fine with that.
So root diagrams are essentially the diagrams of that encapsulate the Lie algebra in this case. So for example, for SU2, remember that we rewrote the three generators J1, J2, and J3 in terms of J plus, J minus, and J3. And what we can do is that we can say, okay, we can express J plus as an arrow and J minus as an arrow. So what this is saying is that J plus is increasing the J0 eigenvalue and J minus is decreasing the J3 eigenvalue. So this is an example of a root diagram. So for SU3, we have 8 generators, and what we do is that our Cartan subalgebra is two-dimensional, right? And we take lambda 3 by 2 and lambda 8 by 2 to be the Cartan subalgebra. And you can see that both being diagonal matrices, they commute, right? So we take these to be the Cartan subalgebra. And then what we have is that we have 6 generators left. And these 6 generators, what we do is that, let's call, say, TA, lambda A by 2. This is just a normalization. Then let's define I plus minus. These are Hermitian and these are non-Hermitian operators. T1 plus minus I, T2. We're just doing what we did for SU2. U plus minus to be T6 plus minus I, T7. And V plus minus T4 plus minus I, T5. Now, if I take these guys and my Cartan subalgebra, what we can do is that we can then, we can associate to each of these guys a vector, which we call root vector, analogous to these things. But since the Cartan subalgebra is two-dimensional, the representation will have 2 real numbers labeling each, each vector, right? Because we have every vector will be labeled by 2 numbers. So the root diagram in the case of SU3 will no longer be a line, it'll be a two-dimensional object. So the root diagram of SU3 will have the vectors associated to these non-Hermitian operators. So there'll be V plus, and then V minus takes you in the opposite direction. So this is the space in which, the X and the Y coordinate are sort of, they're changing these values. And each of these have a structure of SU2 substructure. So, okay, let me draw it a little bit better. So we use, this is V minus, and then this is V plus, and this has a hexagonal structure, I plus, and because of the hexagonal structure of the root diagram, what will happen is that, let me just plug in my iPad so we don't lose the connection. Just give me 1 second. Okay, good. And then we have over here, this is going to be U minus, and this will be U plus. Okay, so do you understand what's happening here? Is that each of these guys are changing the lambda 3 and the lambda 8, values or whatever state that they're acting on. Just as in the case of SU2, these guys, J plus and J minus, they were changing the J3 value or whatever state that they were acting on, okay? So here we have a two-dimensional version of this. And this is a hexagon. So this is the root diagram for SU3. Is it clear why it's three-dimensional? It's two-dimensional? Why is it two-dimensional, not one-dimensional or three-dimensional?
Because it affects two eigenvalues, I think.
Exactly. Yeah, the eigenvalues of lambda 3 and lambda 8. Yeah, because every state will have a lambda 8 eigenvalue and a lambda 3 eigenvalue, as well as some Casimir invariant that we are not interested in right now. Okay. Okay, now let's go to the representations. These are the, so to speak, the gadgets that allow us to move in that representation space. And you will recognize that this has essentially, you will see that they have, all these pairs have a kind of SU2 structure. So essentially, the reason why SU2 was so important is that to create these, higher dimensional, representation of these higher dimensional groups, we use the SU2 that is embedded, the different SU2s which are embedded in them, okay? And kind of use those non-commuting SU2s to move around, okay? I mean, of course, I hope that in a future course, maybe a graduate level course, or you will learn the nitty-gritty of this, because it's actually very beautiful. And Mari Gelman, yeah, no problem, Fahim, you go ahead. I'm not good taking any attendance to this anyway today, so it'll be uploaded soon, yeah. So Mari Gelman reinvented all the mathematics, not knowing that all of this had been solved already by mathematicians, especially Cartan, long ago, okay?